Stop using table for everything. While actually your data fit with graph model, we will see the joint pain when you have a huge number of tables with a many-to-many relationship. And in the case of graph model, there are two language queries that you can decide to use. And we will see the trade-off of them. If you want to use the solution of the name for J, or if you want to use the triple store solution, and we will see the difference of Cypher query. And this video was created using that design data intention application book. This is the 2026 edition, the early access. And thank you for watching this video. Okay, go ahead. Okay, there is an easier way to understand this kind of concept is to see which problem is resolved with graph modeling. And in this case, we can start with some common solution, right? Or some common problem that was resolved with graph. So imagine that you have to create a road rail networking, okay? And you have to compose it in a database. And in this case, you know that road networking is composed with multiple points, and each point is connected between of them. If you want to find which is the shortest path of these points, for example, you have a destination, right, and a started point, you have to compare multiple paths or multiple connection of these paths to find the shortest path. If you want to resolve it with only just SQL, you have to create two tables. One of them it will be the points, and the other one it will be connecting each point. And in this case, you have to create a recursively query to finally to get to all the connection that is in this deep connection, right? So obviously it not will have a good performance, but okay. Another problem that was resolved is if you want to create an social networking. Okay, in a social networking there are multiple users, and the user need to be follow other user, right? So in this case, maybe you can create two tables, right? Only to populate the list of the user, and another table to connect this user with other followers, right? Or following other users. But take in mind that if you want to create a recommendation inside of this user to show some post that is maybe match with the preference of the user, you need to connect each user with multiple insight or multiple hobbies, activities, or movies, or anything that maybe could be works to have a recommendation in some place. So in this case, you not only just think about that only the connection with user, actually could be connected user with multiple hobbies, multiple activity, multiple places. So in this case, you have to create a single table, right, with multiple entities or objects, right, and another that it will be a map this many-to-many relationship. So finally, you can connect all of them, right? So if you want to create an algorithm or logic to get, for example, how many users, it could be like something related with Marvel movies, right? You have to first to understand which category have these Marvel movies. Maybe is connected with the action movies. And you have to get first the list of the user that is matched with action movies, and then there will be user that is connected directly with the Marvel movies. So you have to maybe have a problem with a huge number of the connection of them, and with the regular SQL, it will paint with multiple joins because it will be in a recursivity internally to get multiple dips or categories, right? We will see together in this video which will be the final query if you want to create something like that, okay? So, okay, continue with this concept. Maybe we have to introduce which is the solution of the graph model or how it's implemented actually internally, right? And there are two ways to implement this graph model. In this case, we have an adjacency matrix and adjacency list, okay? Adjacency matrix is when you're trying to connect 2 points or 2 entities only using a table or a 2D structure. It's like you have a list of columns and a list of rows, and they are connected only with a single value. Like in this example, you can see that, for example, the entity A and the entity B is connected because there is a binary value, in this case 1, and when it's 0 because there is any connection, right? So for example, in this case, the B and C is not connected because it's the 0 value in this table, right? And okay, the problem of this solution is that you can create properties in this connection because only you have a single value. But there is another approach that you can implement in this adjacency matrix if you want to create weights. That means that it's not only just could be a one to connect these 2 points. Maybe it could be 5, maybe it could be 10, maybe it could be 20. So with that, it could mean, that number could mean a weight. And this weight, it could be have a context like an okay have a more probability to match with another entity. It's like if you want, for example, you want to create an embeddings like an AI embeddings, right? And you have to get the probability to match with other words, right? So in this case, it's like that. Okay, actually, this kind of adjacency matrix fit very well with GPU or algorithms that is created on the CPU, right? Or embeddings, like I said in this moment, but there is a poor support of reach and edge, right? Because there is a single value. And the next thing is Adjacency that is very used with a web software solution, because it's maybe the thing that you want to create a connection with multiple properties. So in this case, we can see that there will be 2 points here. In this in example, we can see a person and a location. And when we are talking about these entities, it's called like a vertices. And the arrow or the arc in this case is called like edge, right? It's like relationship between two vertices. And the vertices also call it like nodes or entities. And each vertices and edge have properties in this case, right? We have a person that have the property name and the location have the property Idaho. And the edge could have a property like a timestamp, for example, right? And okay, there are two concepts in this case, that is the tail vertex and the head vertex. First, the arrow of this connection, that the connection of this person with location is left to right. In this case, the head vertex will be location, and the tail vertex it will be person, right? In all the cases, there are unique identifier for the person, for the edge, and the location, right? This is the adjacency list. But to see the way to implement this graph model in the case of adjacency list, we can start to talking about the property graphs that is created by Neo for J, right? And in this case, we have an example, right? That maybe you can imagine that is composed this example of graph modeling, right? If a person like call it Lucy is married with Alain and is born in Santa Lo, and is Santa Lo is a city from France, right? And is located on Europe, right? Both person lives on London, right? London is located in England. England is located in Europe, right? And Lucy born in Idaho, United States, and North America, right? The same thing. What happened if, for example, in this example, you want to get the people that who are both, right, born in USA and live in Europe? You can see that okay, Lucy matched with this query, right? Because Lucy born in United States and currently live in Europe, right? So we will see what happens if you want to implement a SQL solution. The SQL solution, okay, like I tell you before, that you have to create two tables: the table of vertices and the table of edge, right? To have a many-to-many relationship. But the problem it could be if you want to create the query to get this data, because it's not only just okay, because because in this case no, there is not a direct connection Lucy with United States. Actually, Lucy only connect with Idaho. So you have to deep internally to get finally if Lucy actually live born in United States and live in London. So in this case, maybe you need to implement a recursivity. And recursivity, you have to first verify if the vertex live in USA, if the vertex live on Europe, right, is located in Europe, and finally if it was born in USA using this in USA and in Europe. And I don't want to deep in this logic because actually it's huge, but you need to know that obviously it can be resolved with SQL, but it's not a smarter way because it will generate a problem to scale this kind of queries, right? Okay, so maybe we can start to see which is a solution with Cypher query that was created with Neo4j. Okay, in this case, I already deployed an Neo4j container, and we have an query with Cypher. Okay, and I will explain what is doing actually this query. It is to start to create in our first data, okay, in this database, and I will in this the first rows is the creation of the continent, right? In this case, North America, Europe, right? And the next thing it will be the countries, right? You have to know that okay, each continent and each country will have a single identifier that is the first word here. USA is an allocation. This location, right, have an properties that is have names and types, right? This location it needs is that type of this vertex, right? Only to take in mind what is doing this query, and then we have to define it, which will be the city and the states, right? Then we will connect all of them with the countries and the continent. But okay, continue with this. We will define the person, that is another type of this vertex, right? And we have a Lucy and a line, right? And then we'll start to connect the state or city with the country, and the country will connect it with the continent. In this case, it's the same. Saint Lo, it will connect it with France, and France, it will connect it with Europe. And London with England and Europe. And the next thing, it will be Lucy, right? Born in Idaho. Lucy lives in London, and the same thing, and is married with Lucy, to Lucy, right? And then run it. What's happened there? So it's done actually. So we can display everything, and to display it only you have to run this query, right? And match and return. Okay, we will see. Okay, and for now it's not clear, but maybe we can see show all the relationship, and there will be an easier way to see which is the relationship. Is obviously disordered, but we can modify here to be better to see. Okay, so in this case, done. Okay, we can see that all the relationships and the connection of anyone, right? And it will be actually easier to see what's happening here. Okay, so we want to resolve what is happening if you want to get the people that lives on London, right? On Europe, I mean, and born in North America or United States. Okay, so the query will be this one. Let's see here more details. Okay. Okay. So the query to get the data it will be like this. Okay, you have to create the match, and you want to get the person that first live on United States within deep with anything, right? Is within is defining which connection have to deep to finally get the matching, right? In this case, we have a person that need to deep that necessary to need to have, right? To locate it the location that, with the name of United States. And the next thing, this is like an aware and, right? And this case is like the person had to be needs to be to lives in Europe, right? And return the person name, run it. And in this case, you will see that okay, the unique person is Lucy. That is done. Okay. So at the moment, you can see that okay, it's very fine, right? But okay, we will see the first advantage if you want to implement this Cypher query, right? And it will be a different with the other ones. And this case is that we can actually create properties on not only just on the vertex. Actually, we can create properties in the connection, isolated. So in this case, for example, if I want to create a new more properties in the connection of the merit of Align and Lucy, we can run this kind of query. That first we have to match or find the relationship that we want to implement. We want to create these properties or add the properties. In this case, it will be the relationship between Alan, Line, and Lucy. And I will add on the relationship that since it's 2015, right? Because it's a married, right? And the ceremony is happy honeymoon, right? and we will run it. What happened here? Okay, it's done. So maybe we can see again, and we will see that if we click on mirror it, we will see that there are properties here. First, there will be an identifier, unique identifier, and then there will be properties that you can use it actually. So it's very, very cool, right? And actually very useful, right? And that's all. So in this case, we can see the difference and the advantage if you want to implement a graph modeling rather than if you want to use a SQL, right? So it's very, very cool. But the property graph is not the unique way to implement graph modeling. And there is another one that is the triple store. And triple store is created by Semantic Web, right? It's a standard in the industry. So you have to take a note that there is an advantage because there will be more data that it was created to support triple store than a Cypher query. So the implementation or the query that you want to implement this kind of data is using ReDF data modeling and turtle format. There are two ways to implement this kind of data. It's like to insert data, right? But the way to query or get data is using SPARQL, right? This is a query language to extract it, but to upload it, you have to use ReDF data model. We will see how is the implementation, right? Okay, and the advantage that the core advantage that you can decide to use triple store if you want to use federate query, okay? But we will see together here. And the triplet store actually have three concepts about this implementation that have a difference with property graph, right? In this case, everything is need to have a subject, predicate, and object. And maybe you have to take a note that okay, subject could be a vertex, right? And predicate could be the edge, right? And the object could be the another vertex or maybe the head vertex, right? But yeah, like sound like in a property graph, but in this case it's different actually that all the properties have this kind of a triplet store. It's like if you want to create a property for a single subject, you have to create a triplet store. So that is the main difference. And actually it will generate more verbose than the property graph, right? But depend of you if you want to implement this. But okay, we can start to see how you can implement a turtle format. And in this case, we can see an example here. Okay, first we have to prefix the domain or the domain. You have to prefix the domain of your website that this is the format because it was created to use it by in the web, right? And I have an example that I can show the advantage that in doesn't have a property graph, but no, it's not something that is better. It's like there is a difference. That is that we can introduce the concept of subclass because there is a relationship with another type, right? Okay, so everything it will be subject, predicate, and objects, right? So in this case, we have the first line. It will be city is a subclass of location. City has a name like like city, right? A state is a subclass of location, and the next one it will be the same thing, right? So we will see you the defining of the first entities, right? And the next one it will deep in particularly properties of these entities. In this case, North America is a continent, right? United States is a country, right? So we are taking advantage of the subclasses to reuse some entities, right? And properties to not need to write again that the name of the city, right? So in this case, we are trying to take the advantage of subclass to not need to write again a property of the city, right? So that is the reason that I define it here, right? But in this case, we have an Lucy, or Lucy is a person, right? Have a name Lucy, born in Idaho, lives in London, right? The same thing. But maybe we can create a subclass that person is a mortal or person is a human, I don't know. So you have to take in mind that you can create subclasses and more things, right? So that's it. This is the turtle format. But there is another format to create data, and this is the RDF data modeling, and it's using XML, right, format, and this is a other way to implement it. Okay, and that's all. Okay, in this case, I deploy it in a container to use Fuseki. Okay, it's in a database that you can run SPARQL, right? And I already uploaded the file to upload data, right? In this case, we already have data populated, right? So it's the same query that I showed you in this video, right? So we have a list of the subject, the predicates, and the object. Like I tell you on the first part is that all the subject need to have a domain that is defined in the prefix, right? The first line. So you will see that everything will be it will be like in a link, right? And that's all. Okay, so that's it. Unfortunately, in this Fuseki, there is not a graph layer that maybe you can play like in a Neo 4J, right? But is useful for us in this moment. Okay, so if you want to implement a query to get the same kind of data, right? The person that born in United States and lives on London or Europe, we can use something like that, something like this. Okay, so this is a query using SPARQL, right? So first we have to create the prefix, because the prefix defines which kind of subject, which kind of data need to be filtered, right? But we can implement multiple prefix if you want it, actually. And the benefit of use prefix is because maybe you can find multiple rows, in this case rows, right? Or triplets store, right? We have multiple rows here, and it could be generated by other domains, right? And you can play with them. So for that reason, we need to define the prefix. And okay, in this case, we have an select, okay, because we want to get a person name. The person name is defined because it's the name of the person, right? And the person born, right, have to born within, right? This is the logic, right? To find the target country. And what is the target country? The target country need to have the name of the United States, right? And need to be a country subclass, right? The same thing in the person needs to live in a live space, and live space need to have the name of London, and it had to be a city, right? So there will be a recursivity, not that, to find the name, right? And in this case, I already have the name of Lucy, and that's fine. Okay. Okay, the first thing that maybe the problem is that there is no way to implement properties like I did it I did it on the case of the Neo4j, right? Like this one. But we have another advantage if you want to implement SPARQL. And the benefit that I tell you before is that triple stories used by web semantic. Actually, there are a huge number of hundred of gigabytes of data in internet, so you can use it actually to populate your data you already have in your local database, and that is maybe the main advantage that you can use. I have an example. That concept is called like a federate query, right? Federate query is when you want to import data and you want to use it actually in your same query. And in this case, I have an example. Okay, so in this case, we have to define the prefix that you will use. I will use my example, right? And then we will use the wiki data, right? This is an data that the data of Wikipedia, right? And is populated using a triple store, so we can implement it here, right? So we want to get the person name, the city name, and the population, right? And to define the population, that okay, in this case, we're going to get the list of a person, right, that lives on the city name and the population of that city. If you want to implement actually manually in your in your own local database, maybe you need to create, maybe you have to update your database to add the population of all the countries, right, or all the continents. I don't know, right? But the problem is that always you need to update that kind of data, and maybe in this case you can be provided by a third-party source, right? And you have to implement it in this case in your query. So you don't need to care about data. In this case, we can see how it's working. First, we have to get the name, right? And the person name is the name of the example org, right? My own data, right? Need to be lives on a city, right? In the city, right? And the city is the name, just that. And I need to have wiki and lives on city, and city only just to show the city name. There isn't any logic about where is lived, only to show the city name. And in this case, obviously, take a note that I already created this triple store, right, in each city. So each city have an URI of Wikidata to be referred, right? Because there is not magic here. It's like to be synchronized with a Wikidata, it needs to be a reference, right? But we will see which is reference I mean. Okay, so in this case, I created a variable that in this case Wikidata link, right? Created a service to connect the SPARQL, right, of this source Wikidata. And then we can use this connection to get the population. Okay, you can see. And finally, we can see it's very, very fast. It's not take too much actually. And we can see that list of the person names, the city name that the person lives, and the population actually. Okay, so it's very amazing. Actually, the population is not stored in my database. It was coming from Wikidata. And to see what is my database, we can run this query. And if we find the London city, we can see that there is another triple store here that refer to London, and the name is Wikidata URI. And Wikidata URI refers this page. This is the Wikidata of London, right? So we can actually think that we can extract any data that come from here. We can get the population, some image, videos, I don't know, native label, native label, pronunciation audio. So everything that is you can see here, it can be populated in my query, and it doesn't need to be upload this data. And actually, the advantage that this kind of data can be updated always, and I don't need to care about that. If we want to implement something like this in in Cypher query, there is another solution, right? It's called it like a poke, right? But the problem of this is that if you want to populate it, here is the data, the source of the data need to match with Cypher or with Cypher query, right? Or with JSON. So it's not flexible. Actually, it's not as standard in the industry, and maybe that is a part that is in disadvantage, right? So you have to decide which one it will better for you. To complete this video, I want to talking about GraphQL. GraphQL is not a data modeling, but it's a data modeling through maybe routing, the part routing of layer, right? And in this case, GraphQL is only located in the part of the API, okay, API, in this case, is when the client generates a query, right? And to get data from any database. It is agnostic actually the database that it's connected. The layer that is connect the GraphQL, the client query to the database is with clear backend side. And usually is used in the online transaction process, right? And the idea is that if you decided to use normalized IDs, front-end needs to call multiple APIs to get the data denormalized, right? So, and in GraphQL, actually, that depending of the display that a front-end want to show, only need to create a query, client query, right, to provide the JSON that front-end needs, and actually not need load any data that front-end not will use it, actually, right? And there is some concept that in this case GraphQL doesn't allow, right? There's no possible to create no recursive queries because obviously there will be the possibility that it will be a higher demand of CPU if there is an recursive queries, right? Like we see before in Triple Store or property graph that it need to deep in multiple connection, right? In this case, there is not an arbitrary search. Actually, anything that you want to query in this query in the client query need to be supported in backend side, right? And there is a strict rate and depth limit because actually the problem of this is that everything will be exposed on a public API, public endpoint, and you have to be careful that not be used by a hacker, right? That want to uh, down your service, right? So that's all. So and so we can see an example here that this is a query client, right? Right, that you can if you want to get data, right? It's like in this case you want to get the recent message, the latest 15 message, because you don't need to all the message. You can use something like that, right? And finally you will see something like this. So that's all. And that is maybe the summary of the graph data ecosystem, right? Thank you again for watching this video. I hope that maybe you can learn some concept that it will be confusing for you. And thank you again, and see you in the next video. Okay, goodbye.